So hey guys, welcome back to another video. Today we'll learn about document store. So yesterday we stopped on key value store, right? So let's learn about another type of database, which is document store, right? So let me write the topic first. So document store. So what is document store? A document store is centered around documents. Like documents can be like XML, JSON, or any binary or a block file. So these are what document store means. We store documents. Where a document stores all information for a given object, right? Document stores provide APIs or a query language to query based on the internal structure of the document itself, right? Now, noted that many key value stores include features for working with values metadata, blurring the lines between these two storage types. So like based on the underlying implementation, documents are organized by collection tags, metadata or directories. So the documents can be organized or grouped together, but documents may have fields that are completely different from each other, right? So we can store this JSON, we can store binary, we can XML, but the data inside that can be different, right? Data can be different in all, right? So that can be different. That was about document store. Now let's learn about wide column store. What is wide column store? So wide column store. What is wide column store? A wide column store basic unit of data is a column name value pair. So it's like a name and value pair. So there is a name and value. Okay. A column can be grouped in column families analogous to a SQL table. Super column families further group column families. So this can be grouped into column inside column so that we can create a hierarchy, we can create a family out of it. You can access each column independently with a row key. So there can be a row key by which you can access all the columns. So like let's suppose this will be row and this will be the column attached to this row. So you can access it. Each value contains a timestamp of versioning or conflict. Google introduced Bigtable as the first wide column store. So Bigtable is the example. Okay, so Bigtable, why I write this? Bigtable is the example of wide column store, and which influenced the open source HBase often used in the Hadoop ecosystem or Cassandra from Facebook. Stores such as Bigtable, HBase, and Cassandra maintain keys in lexicographical order, allowing efficient retrieval of selected key ranges. So that's not important actually. Let's learn about another type of database. Let's learn about graph database. Okay, what is a graph database? Graph database. Let me just search first. Graph database. A graph database is a type of NoSQL database. Of course, we are studying about NoSQL database. These all are NoSQL database to represent and store data, emphasizing relationships between data points. Instead of tables or documents, it uses nodes, edges, properties to model data and their connection. This approach is particularly beneficial for handling complex and interconnected data. So this is how it represents, right? Let me just open some images. If you see how it is. Let me just open a bigger image. So customer is location and order and these all. So this is type of a graph DB. This is a relational DB. So what it says, let me open it in large. While relational database have been to go choice for data storage, they fall short when it comes to handling complex relationships and traversing interconnected data, which puts graph database in a special spotlight. A graph database is a specialized database system designed to store, manage, query highly connected data using graph theory principles. So here we are seeing that it's represented like graph. So the connection is strong between them. These are nodes, these are edge. So 4 can connect to 1, 4 can connect to 0, 3 can connect to 1 and 4. And 1 can connect to all 3 nodes, which is this all 3. 4 can also connect to 3 nodes, 3 can connect to 2 and 0 can connect to 2 and 2 can connect to 2 nodes. Okay. Now what is relational database versus graph data? Both has a relation, but what's the difference, right? Opinion split when it comes to choosing a database. However, the debate around relational versus graph database still hot. Relational database have long been the dominant database model, organizing data into structured tables with a predefined schema. The excel in handling they excel in handling structured data and transaction, but face challenges when dealing with complex relationship and traversing connected data. Traversing means it can be backward traversal or forward traversal. This is largely due to the rigid tabular structure. Just okay. So, joining multiple tables and navigating through numerous relations can lead to performance bottlenecks and complex query formulations. This limits their effectiveness in scenarios where relationships play crucial role. So, if relationships are crucial in your DB, then you should go with Graph DB. If there are many relations, right? Now, as you can see, customer purchase order. Okay, customer resides at location. This order has been purchased by customer. So this order ships to location, right? Now the supplier gets notification. Now supplier delivers the product, and this product is purchased, right? So this product is purchased. Supplier have to deliver this product or ships to the location. So these are the type of relationships that we need to handle. Now graph database excel in modeling and querying relationships. They store connections explicitly, allowing for efficient traversals between nodes and enabling complex relationship queries with ease. And of course graph database provide flexibility, scalability. So I think okay, what else? Characteristic schemaless nature. Unlike relational and graph database are schemaless, meaning they do not require a predefined structure or schema for data. This flexible. Okay, these are object based. I think then if it's a schemaless, then what else can we expect? Graph databases are purpose built for processing the graph data. They employ optimized algorithms and data structures to efficiently traverse and manipulate the graph structure, resulting in faster query response times and improved performance compared to non-native graph database. Okay, so that was it about this sort of database. Now let me go to Nito again. So that was about graph database. It's recommended when you need more relation and or relationships. Relationships are complex. Okay, if relationships are complex, then you can use graph database. Where else can we use it? Of course, we can maintain relationships. And what else is there? Just a second. They employ optimized algorithms, unlike okay, this is also schemaless. That is also awesome thing. One more benefit is schemaless. Schemaless, which means I think it might be storing in JSON format or some object format. Format. It's just my guess. We have to check. We have to go in more detail to understand more. So this was all about NoSQL database. So what we have learned, document store. Wait, there is first key value store. Of course, this is the first one. NoSQL database. Document is second one. NoSQL database. Third is what? Wide column store. Fourth is graph database. These are NoSQL database. Now let's learn about RDBMS, Relational Database Management System. Okay. So what are the concepts in this? Okay, RDBMS, Relational Database DB Management System. Okay, so this is what RDBMS means. Now let's learn about the first concept, which is replication. Okay, what are type of replications? We have already learned about it. First is master slave replication. Okay, MS replication. So what is master slave replication? Master slave replication means let's keep it down. The master serves reads and writes. Okay, so there will be a master server which it will serve R and write. Okay, slave will just serve reads. Replicating writes to one or more slave which serve only reads. Slaves can also replicate to additional slaves in a tree-like fashion. So let's suppose this is the main server, then we have slaves. If there is one slave can be copied by more two slaves. So let's say this is the root, this is S1, this is S2 slave, this is S3 slave. So if S1 gets, S1 keeps on copying replicating all the data from the master. Let's suppose this is master. Then what S2 and S3 can do, they can also replicate. This will serve for read and write. This will serve for read. This will also serve for read. If master goes down, then this will become master. Okay, so this will become master. So that's how it works. Master application. Master application. This will be MM application. So what is MM replication, which is master application? Both masters serve reads and writes and coordinate with each other on writes. If either master goes down, the system can continue to operate with both reads and writes. So in this case, both will be root, both will be masters, right? Both will be masters. If this goes down, this can serve read and write. So eventually there will be some load balancer which will serve the request to both of this, which will balance the request between both of them, and that will make sure that both are serving read and writes. So this will also serve read and write. This will also serve read and write. So that's how it will work. That's how our application in master architecture works, and master slave architecture as well. Now let's learn about sharding. What is sharding? This is a very interesting concept. Let's learn about sharding. Okay, database sharding. So what is sharding? Sharding distributes data across different databases, such that each database can only manage a subset of the data. So sharding means that we distribute data across a different database, which means we have different database according to the requirement of our data. Like taking a user's database as an example, as the number of users increases, more shards are added to the cluster. Similar to the advantage of federation, sharding results in less read and write traffic. So let's learn about sharding first to let me understand. Sharding database. Database sharding is a method for horizontal scaling a database by distributing a single dataset across multiple database instances. Okay, so what we can do, let me show you this example. As you can see here, this is the database, right? So what we have done, we have sharded the database. We have created the $0 to $49 that will be in one database. The 50 to $9.99 price will be in another database, and the products which cost more than $100+ that will be stored in another database. That's how sharding works. Right, so we can do horizontal partitioning. This is horizontal partitioning, right? Sharding is a form of horizontal partitioning, meaning it divides data by rows rather than columns. So divided by row, right? So rows are divided rather than by column. Each shard contains a distinct set of rows from an original database table, which maintaining the same schema. So that was about sharding. We have a DB. Let's suppose this is our DB. There is some conditions from which we can separate these rows. So let's suppose we separated this row, we separated this row based on some conditions. So this will be another table, this will be another table. So we can shard it, okay? And this can be continued at infinite times until there is any large value, right? Similar, what are advanced sharding results in less read and write operations because we have divided it, right? Traffic, less replication. Replication is also very less because data is divided. So only the required data we can replicate, not all. Less replication. Now what else? More cache hits. So cache hits are more because people won't be needing to come to the server for data, right? We can store in cache it at Redis using Redis or anything. So index size is also reduced. Index size is also reduced because we have divided the data. So of course the index size is reduced. Okay. Now, if one shard goes down, the other shards are still operational. Also, you will want to add some form of replication to avoid data loss. So if these are our shards, and if one is gone down, other will be up. But what we have to maintain some architecture, so that we need some slaves. This will be master. So we need to make sure that data gets replicated, and this will be up and serve the traffic, right? Like federation, there is no single central master serializing writes, allowing you to write in parallel with increased throughput, right? Throughput we have already seen how many users our server can serve at distinct time at the same time, right? So throughput should be it will increase throughput because data is small, read and write will be faster. It won't need to traverse through much data because data will be less because we have sharded everything, right? That's about sharding. Now let's learn about federation. What is federation? Let me just write the topic. Federation. My handwriting is very bad, guys. Let me just improve it. Federation. I'm not sure why it's so bad. Federation. So, federation or functional partitioning splits up databases by function. Or for example, instead of a single monolithic database, you could have 3 databases. Okay. So instead of monolithic database, what we can monolithic means a single database where you are storing everything. So what we can have? We can have 3 databases, for one for forums, one for users, and other for products. Okay, so we can have this three database, resulting in less read and write traffic to each database and therefore less replication lag. Okay, so if we have this three database, we can replicate that. Okay, but the thing is, it will also, we will just replicate the required things. Let's suppose users getting more query, right? So we can replicate that in two servers. We can replicate this as well, products as well. Forms, I don't think it require much replication, so one server would be enough for that. A smaller database results in more data that can fit in memory, which in turn results in more cache hits due to improved cache locality, right? So if we have implemented this, so let's suppose there is load balancer where we are caching these things. So we are maintaining cache here. So if request comes, a load balancer can cache our things, right? It can cache user and send data back to the user from load balancer itself. Otherwise, it needs to query this user table or product table or firms DB. So with no single central master serializing writes, you can write in parallel increasing throughput. Here also we can increase throughput because there is no single master, right? Every data is its own master. So that will increase the throughput. That will make sure that one server can serve as many users as it want to. DB can serve as many users as it want to, right? That's about federation. Now let's learn about denormalization. Okay. Let me just save some space. Why? Denormalization. Okay, what is denormalization? Uh, So, guys, if you know about normalization, what is normalization, right? So, let me first explain you that normalization. So, see, what is normalization? First of all, let's learn about that. Normalization. What is normalization? So, like the process of organizing data to reduce redundancy and improve data integrity, right? Redundancy means the repeated data, the data that's already there but has multiple copies. So, reducing that is known as normalization. It will also help in having increasing the read operation and the throughput because there will be less rows to query from, right? So this is achieved by dividing data into smaller well-defined tables and establishing relationship between them. So if you have a huge table and of course after reducing the redundancy and all, still the data is huge, what we can do, we can divide that data and we can divide that table. Okay, and dividing is also part of what? Sharding, right? We are doing sharding here. So normalization, sharding also take place here. This will make sure that redundancy is decreased. Okay, data and also we can maintain a relationship between them. So let's suppose that some price $0 to $100 is this, then 100 to what? So we say $200 is this. Okay, so 101 to $200. Products are in this and others are in this, so we can divide it like that. Now comes denormalization, right? So denormalization is what? Denormalization means the intentional introduction of redundancy into a normalized database. So once we have normalized the database, right? After that, what we can do to improve read performance specifically by reducing the number of joins required for queries. Here we have created joins, right? We have created these joins. Now, reducing the number of joins, we can make sure that read operations become faster, right? So, like it's a technique used after normalization. It's used after normalization, which means it's after normalization, and it's not a replacement for it. It involves adding duplicate data or pre-calculating values to speed up data retrieval. So we pre-calculate values to speed up data retrieval, right? So that's it. Now key aspects of denormalization. First is purpose, to optimize query performance by minimizing the need for expensive joins, especially in read heavy applications. So denormalization we do it for basically making making sure that the operations are faster. Now comes what is difference between normalization and denormalization. Normalization versus denormalization. Normally, there are two contrasting approaches. Opposite of that, to database design, each has its own strength and weakness. Normalization aims to reduce data redundancy and provide data integrity by organizing into multiple tables and define relationships. That's what we saw, right? Denormalization, on the other hand, adds redundancy by combining data from multiple tables into fewer, often larger tables to improve query performance, particularly in emergency scenarios. So in normalization, we reduce redundancy. In denormalization, we add redundancy by combining data or pre-calculating the values. So that's the difference. Of course, the name itself is contrasting normalization and denormalization. So that was expected. Now let's learn about SQL tuning. What is SQL tuning, right? Let's learn about SQL tuning. What is this? So SQL tuning is the attempt to diagnose and repair SQL statements that fail to meet a performance standard. So we write a lot of SQL queries, right? To improve that is known as SQL tuning, to improve the performance. It is a broad topic and many books have been written as reference. It's important to benchmark. Of course, nowadays you don't need to read books. I would say that use AI to fine tune your SQL queries. Use AI to fine tune your SQL queries, right? Now what you can do now, there are tools, let me show you. SQL tuning tools using AI. So if you search this, you would find a lot of AI SQL optimizer, enhance SQL performance, free SQL optimizer. So you can go like Even is very famous, I would say. Even is famous, I have heard this name. So here you can write your query and it will try to, let me just show you next. Analyzing the query is being analyzed, this process, okay. Now, of course, you have to get a paid plan to do this, but it will improve your query and thus it will improve your performance. So that's about RDBMS, Relational Database Management System. NoSQL we have already saw. Now let's learn about caching. What is caching? This is also a very interesting topic. Let me see if it's recording or not. It is. Oh my god, I was streaming.